Hello students. So now today's session we are going to start integration, and we will see some important formulas in integration and what is the physical meaning of integration, and then gradually we'll move forward. Okay. So integration. Let us start integration. So first of all, we have to understand integration that it is an opposite process. It is an opposite process of differentiation. Opposite of differentiation is integration, and it's a process. It is a operation, mathematical operation. So let's understand that. For example, suppose if I take let us take x square. Differentiation of x square with respect to x, that it is 2x. This is differentiation. So here y square you have differentiated and you got 2x. So now if you do the integration of 2x with respect to x, okay, so this is how integration is written. Integration, this is the symbol for integration of 2x. Here this is the function, okay. Dx means with respect to x, okay. So that will become equal to x square. That means if you do 2x integration with respect to x, you will get x square. It is just the opposite, you can see here, right? It is just the opposite of differentiation process. Similarly, let's say if I differentiate ln x with respect to x, log ln differentiation is 1 by x. So just the opposite of this will be integration. Integration of 1 by x dx will give us ln x. Okay. So this is what is integration. So basically integration is written as integration of y dx. Okay. So that means it is integration of y, which is the function here, y with respect to x. This is what it is, integration of y dx. Now let us understand what is the physical meaning of integration. Physical meaning of integration, let's understand that. Okay, physical meaning of integration. Physical meaning of integration of y with respect to x. What does that mean? So again, as I told, from the graphs we have to understand, right? Graphs. So let's draw the graph. Let's say this is y graph, this is xy graph. Xy can be any quantities. Let us say the graph is like this. Okay, it is a function. So let us say that there is two values of x I am taking. Let's say this is x equal to x1 and this is x is equal to x2. Okay. So if I want to find out area between the graph, suppose I want to find this area under this graph. Under this graph means with respect to x-axis. With respect to x, so this area if I want to find out. Okay. So how do we calculate this area? So you can try to divide this x difference into small strips. Let us say if I divide it like a strip. Okay, here I am not going to derive full but basic idea you have to understand what it is. Let's say this is a small delta x. Okay, this is a small delta. So here I am going to make a strip, right? This is a strip. This is a strip here. Okay, this strip, the thickness of this strip along x-axis is delta x, and let's say this is some general value of y, because this you can take as x. Okay, this point you can take as x, and then this will be your y, isn't it? This value will be your y. If you want to take a small area, that you can write delta a small area, what you can do is you can try to make it like this. Okay, let's say you make it like this area you try to find out. This area simply will be what it will be, delta A, it will be y into delta x. Correct. This is a single strip. Similarly, you can keep on adding such strips. This is just, one strip I have taken. This is strip. But you can keep on taking many strips, like here one strip, here one strip, like that. You keep on adding that, right? Okay. Yes, that means you need to divide into many number of strips, and you can keep on adding. So the total area, I can say total area, let's say A, is like summation of all these areas, right? Summation of all this area means it is y into delta x. It is summation because right now this delta x is like some finite values. Delta x is small strip length. But if I make this delta x very small, that means I am going to apply limit. Why? Because this area which we are calculating will not give the exact area. Why? Because when you are taking this strip, there will be some portion will be left. For example, you take this strip, and when you take next strip, it will be like this. Okay, so you will be leaving some area here. So some area, this will be left area left, while you are adding. You are understanding, like suppose this strip, then next strip, then next strip, like that. When you are adding, so the graph may be like this, and some areas will be left out, right? Here small areas, these areas will be left out, so this will not give the exact area. So in order to make the exact area, you have to keep this delta x to be very small. So that's why the exact area A will come as applying limit delta x tends to 0, this summation which we are doing. Okay, now this is what is called integration of y dx, and of course integration you are taking between the limits, so there will be x1 which is lower limit, there will be x2 which is the upper limit. So this x1 is the lower limit, this x2 is the upper limit, and this is integration of y with respect to x. So this is what is the total area, because when you take very small strip or negligibly infinitesimally small strip, it will give the exact area, right? So that's what it means. Integration represent area under the graph between two limits. If limits are not there, that is called indefinite integration, right? So limit has to be there, so that is called definite integration. So integration are of two types. Integration are of two types. One is definite integration. Just now we discussed about definite integration. Definite integration means you will represent it as y dx. Again, y is a function of x, right? And some lower limit, some upper limit. Okay, so this is called upper limit. Upper limit means maximum value, and this is called lower limit. Lower limit means minimum value. Okay, that's what it is. Similarly, the second type of integration is indefinite integration. So in indefinite integration, you may write this as y dx without any limit, but when you are going to evaluate it, right, you have to add. So you will get some result, but you need to also add a constant of integration. Here c is constant of integration. So in the answer you have to add, because the answer will not be definite, so you need to add particular value of c. That will depend on what the limits will be. Okay, so in such cases, after evaluation, you have to add a constant of integration. Okay, so these are the two types of integration. Now we can see some important formulas in integration. Okay, so let us see polynomial function. First of all, let's take polynomial function. So if you are taking, let's take, so first important formula is integration of x of power n dx. What is integration of this? So it will be x of power n plus 1 by n plus 1. Remember, and of course constant of integration you can add if there is no limit. And here what will be the value of n? N should not be equal to minus 1, because then denominator will become infinity. So for n minus 1 this is not the case. What will be the case for x n minus 1? That means it will become 1 by x dx. That already we discussed. 1 by x is ln x plus c, right? Similarly, you can do for different cases, right? Suppose it is 1 by x square. 1 by x square different integration with respect to x, that will come minus 1 by x, okay, plus constant. So in this manner you will be able to do that, okay. All such calculations can be done in this manner. These are some basic fundamental, formulas, but separately also I will be sharing different formulas for different types of functions, okay. Then let us take trigonometric function. If you take trigonometric function, then you take integration, just like differentiation of sine is cos, so integration of cos x with respect to x is sine x, right, plus c. Similarly, integration of sine x dx will be minus cos x plus c. Then similarly, integration of secant square x dx is tan x, because tan x differentiation is secant x. Similarly, integration of secant x tan x dx, that is secant x plus c. Similarly, what about cot x differentiation? Cot x differentiation is minus cosecant square x. So similarly, if you do cosecant square x dx, you will get minus cot x plus c. Same manner, if you do cosecant x into cot x dx integration, then you will get minus cosecant x plus c. Okay, so this is just the reverse of the differentiation formulas. This we should note, right? Then we will continue further in the next class more about the different type of integration formulas. Thank you.